Just on demand, someone have asked me to solve and explain this question or explain principles of mathematical induction using this question, right? Okay. Um, please do wait to subscribe, like the video, and comment, and put in more questions. If there are questions in chemistry and mathematics you need me to solve, just put it in the comment section, right? Okay, now using PMI, prove that 6 raised to power n minus 1 is divisible by 5. All right, so if we have to prove this, we first have to understand the question. We have to understand the question. Now, they say we should prove that this is divisible by 5. So it's like someone saying, okay, this is white, prove that is white. Or um, it's like an established fact. I need you to see it from that way, and then you are asked to prove that fact, right? It's not more like they're asking you to check whether it's wrong or right. You need to understand it, because I think that's where many students get confused. You are not asked to check whether it is right or wrong that 6n minus 1 is divisible by 5. They are telling you that it is divisible, then you should prove it, right? Okay. um Having said that, if this is divisible by 5, what are they demanding from us when they say prove that is divisible by 5? What actually are they demanding from us? They are trying to tell us that we should prove that this thing is a multi this is this thing here is a multiple, of 5. For something to be divisible by 5 means that is a multiple of 5, right? So what they're telling you is that 6 raised to power n minus 1 is equals to 5 times something. Do you understand me? I hope you do. So this is what they're trying to tell us, that 6 raised to power n minus 1 is equals to 5 times something. We don't know what that something is, but we know that this is a natural number, because principle of mathematical induction comes when we are trying to validate the efficacy of natural numbers, right? Okay, so we're asked, I'm just giving you another interpretation. 6 raised to power n minus 1 is equals to 5 times certain natural number, then you should prove it, right? So there are two approaches to proving anything in PMI. The first approach is called the base case. We will have to consider the base case. Then we have to consider the second approach, which is the inductive case. The inductive case. The base case is literally when we substitute, because we are dealing with natural numbers, when we substitute n with 1. So in the place of n we have 1. Is it divisible by 5? That's what we start to prove. If what is here, if n is equals to 1 for base case, if n is equals to 1, is it divisible by 5? Then let's check. If n is equals to 1, we have 6 raised to the power 1 minus 1, which will give us exactly 5. Of course, this is divisible by 5, so this is correct, right? So we have already interpreted this question. Then the next thing is to go to the inductive case. I call this the inductive case. Sorry, I didn't put it well. The inductive case. So in the inductive case, we are now to assume that n is unknown, and we are going to take two values of n, one particular unknown value of n and the next unknown value of n. Let me give you an example. This is a natural number, right? 1. The next number to this natural number is what? 2. The next number after 2 is what? 3. The next number after 3 is what? 4. So we are going to assume that n is unknown, and then we will have to prove that it's also divisible by 5. And how do we know that it is divisible by 5? It should give us 5 times something, and whatever this is, we know it's going to be a natural number, right? So 5 times something, of course an integer also. So once we see that this 5 is multiplied by something, if we can resolve it into this form, it means that it is divisible by 5. It's very important that we understand the question. So for the inductive case, we are going to have n equals to k is unknown. We don't know what the n is. N here stands for any value of natural number, right? We don't know what it is. So we are going to substitute nk minus 1 is equals to 5n. Of course, we know that this k is unknown, right? So here is literally the same thing we are saying here, 6n minus 1. But here n is now representing k is equals to 5m. And this 5m is more like saying this is 5, a multiple of 5, right? Okay. And this is what we are trying to prove. So it's assumed because this is exactly like this, so is equals to 5m. Then the next thing is 6. We have to assume, we have to prove it when with the next number after k. We don't know what k is, just like the next number after 1 is 2. And how do we know 1 plus 1, right? So the next natural number after k should be k plus 1. So we have when n is equals to k plus 1, is it divisible by 5? You now see that this value here and this value here are not the same. This and this look the same, but this and this will not be the same. So we are going to have 6k plus 1, right, minus 1. And we are to prove that this is divisible by 5. So literally what we are going to be doing here is that we are going to be applying some mathematics, we are going to be doing some manipulations which will not defeat the integrity of mathematics as well. You must make sure that the manipulations you are going to use are still strictly under mathematical laws or mathematical rules, right? So we are trying to transform this to see that if we can get a transformation of this that could look like this, right? Okay, so here we have 6k plus 1, and we know in our law of indices that when you have a raised to power n, right, times a raised to power c, you can say is a n plus c, right? So that is what we are going to apply here. So here we are going to now turn this back to this, and we'll be having 6, right, times 6k. So this is 6 raised to power 1, and this is 6k. So it's the same thing as saying 6 raised to power k plus 1 from this law, right? Okay, minus 1. It has not still given us what we are looking for. Then what other manipulation can we do to get what we are looking for? What other manipulation can we do? If you think very well, there's another manipulation we can do either here or here. All we want is to arrive at something that can give us 5 times something, right? So the next manipulation that we can do, here we already have 6, so I can bring this out, 6 raised to the power k, right, minus 1. Then the next manipulation, what I'm doing, 6 raised to the power k minus 6 plus 5. Now, you see, I did a manipulation here, but it doesn't change the law. This thing is still the same thing as saying minus 1. Minus 6 plus 5 is still minus 1, right? I'm just trying to manipulate this to see if there's a way I can manipulate this to look like this, but it's still this, right? Or it's still this. I'm trying to manipulate this to look like this, but it's still this. Okay, so permit me to okay, I hope you are following. Here you see that we have like terms here, so I can factorize this 6 out, right? So we are going to have 6. If I factorize this 6 out, this is a multiple, this like saying 6 times 1, so we are going to have 6 raised to the power k, right? Then minus 1, right, plus 5. And we know that this is actually what we're asked to prove. We were told that this is equals to this is not equals, is a multiple of 5. And here we have it here, 6n minus 1 is a multiple of 5, and we have 6k minus 1 is a multiple of 5. So this multiple of 5, we are going to put it here, right? Okay, let me come over here and do that. So we are going to have this particular one here, 6k minus 1 is the same thing as having 6k what, minus 1. I can remove this bracket if it will confuse you. So you see that this value here and If I remove that bracket, of course, you know it's not going to affect it. So you know that this value here, minus 1, 6k, 6 raised to power k minus 1 is the same thing we have here, it's the same thing we have here, which is a multiple of 5, all right? So I'm going to replace that with this 6, open bracket, 5n, right? Plus 5. Okay, I want to be sure that you are seeing what I'm doing. Sorry, it seems like you are not seeing. So of course, now you see we are having we are having we are having 5 6 times 5m. The 5 is this 5m we know is from this 6k minus 1 is a multiple of 5. 5 times something is 6k minus 1, right? So we are putting this 5m in place of this, and you see here we can also do a little bit of factorization. We can do a little bit of factor, or perhaps let me not factorize. So 6 times 5 will have 35m plus what? 5, right? So here, now let's do the factorization. I don't want to do it directly. You see that this is divisible by 5, this is divisible by 5. So we have 5 6m plus 1. Now you see that for us to have 5 times something, and we know that this is a natural number, and it should be an integer also, but it's certainly a natural number. So we know that this 5 times 6m plus 1, we don't know what this is, but all we know is that 6k plus 6 raised to power k plus 1 is equivalent to 5 times 6m plus 1. For it to be multiplied by 5 means that certainly this is a multiple of 5. So having this in this form has successfully proven that 6n minus 1 is indeed a multiple of what? 5. So, and that is all for today. Once again, please do well to subscribe to the channel and put in your questions, especially chemistry questions. But I want to read your comment in the comment section, and also hit the like button and the subscription button. All right, have a very nice day.